All right, welcome everybody. We're going to do Unit 1 multiple choice and from Calcmedic. So let's start on the first one. It says find the limit as x approaches negative infinity. Hopefully you remember that we have some type of function and we're moving as our x values are getting smaller and smaller. We want to know what is our y values doing. And so the first thing that you do with limits approaching infinity, you're going to look for that horizontal asymptote. So I'm just drawing an example. If I have a horizontal asymptote, whatever this function looks like, the end graphs are going to be approaching that horizontal asymptote. So that's what you're looking for first. So let's take this and multiply it out. So we're going to be left with 2x squared minus 5x, and then multiply that with 8x minus 1 all over 8x cubed minus 1. So now let's multiply this out. If you want to use FOIL, you can. 2x squared minus 5x and multiply it by 8x minus 1. 16x cubed minus 40x squared minus 2x squared plus 5x. So that's going to leave you with 16x squared minus 42x squared plus 5x all over 8x cubed minus 1. So now as we find the limit, we actually know how to compare our polynomial at the top and our polynomial on the bottom. Okay, and this is a negative. And whenever we have the degree, we have the degree of 3. They are equal. So because they are equal, that means that we can divide the coefficients. So that means we're left with 16 over 8, which is 2. Keep it pushing and move on to the next one. All right. So number 2 says a function f has the property that as x gets sufficiently close to 4, okay, so that's the whole definition of limits. If we say something is getting closer to 4, it doesn't say from the right side, it doesn't say from the left side, but we know that as we get closer and closer to 4, it says, but it's not equal to 4. The value of f of x, okay, gets closer and closer to what? Okay, so that's the whole purpose of limits. What is happening with your y values? So it's getting closer and closer to -1. So they could say as x gets sufficiently closer to 4 from the right side, maybe they may some say from the right or the left, but it just says to 4, so you're assuming from the left and the right side. So the answer to this one should have been C. Okay, so let's go to number 3. Number 3, all right, so now it says we have a piecewise function. So remember, on piecewise, you're always looking for which one is going to be more on the right side, which going to be on the left. So right here, I usually would like to say that if we look at this one, this would be more of the right side, even though it stops at 0. And this would be more of the left side, okay, of 2. So the right side, nope, wrong. Erase all of that. Okay, so this would be the left side because we're looking at numbers that are smaller than 2 on the number line, and this will be our right side. There we go. And those are numbers on the number line 3, 4, 5. So those will be on the right side. Now, what it asked us is then the limit as x approaches 2. So that means we're going to have to check the left side of 2 and the right side of 2 and then see are they the same, or if they're different, then it'll be non existent. So let's plug it into the left side. All right. And we're going to plug in that 2. We're going to say e to the second power plus e to the second. Okay, so we're going to plug in that 2. We're going to combine like terms, so we're left with 2e to the second. That's what our left side limit is once we do direct substitution. So now let's try our right. And we're going to be left with 2 to the second power times e to the second minus 2 times e to the second. So we are plugging in 2 for each one. We're going to get 4e to the second minus 2e to the second Combine like terms, you're left with 2e to the second. So the limit from the right side is the same as the left, which means that our limit is 2e to the second. So that's what you should have had for both. All right, so moving on to number 4. So for number 4, it says, even though it looks a little tricky, you always start off with direct substitution. So as the limit of x approaches k, and it says k cannot equal 0, it says, what's that limit, right? So let's do some direct substitution. So we're going to say, we're going to plug in k for every single x. So we're going to say k to the second power plus 3k minus k times k minus 3k, right? So we're changing all our x's to k. So then what you're going to see is you get k squared plus 3k minus k squared minus 3k all over k squared minus k squared. So this is going to give you 0, that's going to give you 0, and this is going to give you 0. Boom. Whenever you get 0 over 0, that means you can use L'Hopital's rule, right? So now let's use L'Hopital, and that means do something else, right? And so we're going to take the derivative of the top and derivative of the bottom. But don't forget that k is a unknown number, right? So as you treat this and try to find the derivative, remember it's a number that we don't know. It's some type of constant, right? It's an unknown number. So let's take the derivative of x squared plus 3x minus kx minus 3k. So we're going to use power rule. We're left with 2x plus 3 minus, remember, if I took the derivative of 3k, or sorry, if I took the derivative of 3x, that will give us 3. So if I take the derivative of minus kx, that's going to give you just k, because we don't know what that number is. And then lastly, if I take the derivative of negative 3k, that's just a constant. We don't know what it is. Is it negative 3 times 1 times 2? We don't know what it is, but we know it's a constant, and the derivative of that is 0. So I'm going to write the 0 just so you know what happened to it. And then take the derivative of the bottom. We're going to be left with 2x. And remember, this is also the derivative of another constant, so it goes away. So we're left with 2x plus 3 minus k all over 2x. So we're back to our limit. So now that we took L'Hopital's, let's plug back in the k. So you're left with 2k plus 3 minus k all over 2k. And then let's combine like terms, and you're left with k. Oh, it's looking a little fuzzy. You're left with k plus 3 all over 2k. Okay, sorry I got a little messed up at the end, but yes, your answer is going to be A. All right, so let's look at number 5. Okay, it says let f be a continuous function. It says let f be a continuous function on the closed interval. All right, so we know that it is continuous already. It's already stated. Remember back to algebra 1, such that I plug in a -2, my x, and my output is a y4. I plug in a 6, and out comes a -4. It says, which of the following is guaranteed by the intermediate value theorem? So remember, for IVT, step 1, you have to make sure that is a continuous function, okay? And we will never find the c. We're looking for that there exists some c, right? There exists some c as long as that output of that C falls in between 4 and -4. Okay, so your answer guarantees by IVT, it has to be C, because we don't know what X value that's going to be, but we know that if the output of that value is a 1, and if that output falls in between 4, let me erase that. If that output falls in between -4 and 4, you're all good to go, right? So that 1 falls in between there, then that means that by IVT, that there exists one C okay, on the interval from -2 to 6. This one is trying to trick you. It does fall in between 4 and -4, the output. However, it we don't know for sure what can happen and if it's going to fall in between 0 and 4. The only thing we know for sure is that it has to fall in between that interval of -2 and 6. Okay, so always make sure the y value is in between the two y values of the interval. Okay, so this was our interval and this was our interval. All right, so let's go to number 6. All right, it says the graph of the function shown above, which of the statements is true? So let's look at it. F is continuous at x equals 2. That is incorrect. It is not continuous. F is continuous at x equals 5. All right, that one's looking good. It is continuous at 5, but let's just check the other ones. F is continuous at 6. Nope. There's a jump. It's continuous at 8. There's a vertical asymptote. And then lastly, 9. Nope, there's a hole. So the answer for this one is B. It is continuous at 5. All right, the table above shows values of a continuous functions f and g and their values at the selected values of x. All right, it says if h is a continuous function defined by this, it says then the limit as x approaches 0 for h of x equals what? Okay, so whenever we're looking at this, right, we're still going to do, we need to find out what is the limit for each of these functions. So if we say find the limit as h approaches 0 for h of x, you can actually say what's the limit as x approaches 0 for f of x times the limit as x approaches 0 for g of x minus the limit as x approaches 0 for 2. Okay, so let's look at each one and figure out what it is. So let's look at just f of x. All right, so we're looking as x approaches 0, right? And so that means you're going to look at this right here. This is telling you as x approaches 0, so which is going to be right in the middle. Okay, so this is approaching 0 from the left side, from the right side, and as you can see, it's going to be 5. All right, oops, boom, boom, boom. Let's see, hopefully it's not too dark. Oh, it's going to erase it. I don't have my other one. Okay, so if you look right here, boom, from the left side and right side, it's going to be 5. Okay, so we know the first one, that the first one is going to be 5. Okay, then the next one, it says find the limit as x approaches 0 for g of x. Okay, so now if we look at the next one, okay, boom, let's look right here. From the left side, it's going from the left side as it's coming from the x value. All right, it looks like it's approaching 0. We have here, here, here. And then from the right side, it's also approaching 0. So remember on the y-axis, it's going to be coming from the positive, and on the y-axis is coming up from the negative. So that means this is actually 0. Okay. And then we're going to subtract the limit as x approaches 0 for 2. These colors look terrible, y'all, but that's all right. It's all right. Okay. So x approaches 0 for 2. And hopefully you remember that that is just a linear line, right? And the function of this, every single y value is going to be a 2, right? And so if every single y value is going to be a 2, that means your answer is just going to be -2. Okay. So this answer is going to be -2. Ooh, y'all, this is too thick. Ooh, it's too thick. That is all right. Okay. And so remember, anytime you have a oh, sorry, if you just wanted to graph that, right, and this is a linear line, no matter what, it's always going to be to your y value. Okay. Let me change the thickness of these lines because that got a little out of hand. All right, let's do that one. Okay, so we're almost done. Let's look at 8, 9, and 10. Okay, here goes our graph. It says the graph of f of x has a horizontal asymptote. So hopefully what you remember from asymptotes is you can find it by looking at the degrees of the polynomial from the top and bottom, right? Big on top, stop, right? Um, if it's bigger on the bottom, okay, so if they're the same, you could divide the coefficients. And then if it's bigger on the bottom, then it's going to be 0, okay? So let's look at this one. We have negative. I actually am going to switch the order. So negative bx plus a all over negative x plus c. Okay. And so let's look at the first piece of information. It says the horizontal asymptote is this. Well, hopefully, what you notice is these have the same degree. So whenever you have the same degree, you can divide them. So I have negative b over negative 1. They have the same degree. So let's divide the coefficients. And when I divide the coefficients, my horizontal asymptote should be negative 6. So you're making these equations off of the information that you have. So let's multiply both sides by negative 1. So you're left with negative b equals 6. Divide, and we just found out that negative b equals negative 6. So we found our first one. We'll put that information on the side. Actually, let me clear it. Okay, so we know b equals negative 6. That's just terrible writing. Let me try it again. Okay, b equals negative 6. All right, so then vertical asymptotes. You find vertical asymptotes on the bottom, right? So if we have a vertical asymptote, we're going to have c minus x equals 0. Okay, so whenever you set the bottom to 0, that's how you find your vertical asymptote. So right now, if I solve this equation and I add x to both sides, we just found out that c equals x. So in order to find out b plus c, I know what b is, I don't know what c is, but they tell us the vertical asymptote of x is going to be 6. So that means that we can substitute that x in, and we just found out that c is going to be 6. So we'll take negative 6. Oops. Here we go. All right, so we're going to take negative 6 plus 6, because that is b plus c, even though my 6 looks like b's, and that's going to give you 0. So your answer should have been 0 if it wants me to circle it. Okay. All right, so let's look at the last two. Okay. Let's see if I can clear all this. Okay, so then we have 9. All right, it says the function of f is given by this. It says how many positive values of c does this give us? So I think on this one was a calculator one. And so we're actually going to pick up calculators this week. So just in case some of you guys uh, need to figure out how to do that. And so right here it says, for how many positive values of c does the limit equal 4? So that means from the left and right side, it's going to be approaching 4. So let's open up a Desmos and put that in there. Okay. And so we have f of x equals x cubed. Okay. And then we're going to have minus x squared. All right. Plus 20x minus 12. All right. So what you're going to see right here is we're looking at how many times is from the left and the right side is um, right here, is it going to be positive x values? So they have to be positive x values where the limit is going to be 4. So you actually have it twice. You have it right here. So from the left side and from the right side, it's going to be 4, and it's a positive 2. So at x equals 2. And then you also see it again right here. Okay. at 4. So that is going to be 2 times. Boom. That should have been your answer. Okay. And then on the last one, number 10. All right, we're back to that direct substitution. So we're going to say, let's plug in 0. So we're going to say 0 over sine of 0. And hopefully you remember from the unit circle right here, this is going to be 1 comma 0. This is cosine, that's a sine, and that's going to be 0. So we're left with 0 over 0. Uh-oh, that means do something else. So that means that we can do L'Hopital's. So let's take the derivative of the top, which is 1, and the derivative of the bottom, which is going to be cosine of x. And now let's substitute again that 0 into our equation. Sorry, not our equation, into our limit. So we're left with 1 over cosine of 0. And the cosine of 0, which we already have right here, is going to give you 1 over 1, which is 1. All right. So let me know if there was somewhere where you got lost, even the video didn't help, and I'll catch you guys on the next multiple choice.